And this is Sai Fanendra from SQL School, caretaker, and I would be the only person for Azure in our school. I want to be the only one. I will be the only one, so that things are straight to the point with utmost care. I assure you 100% practice oriented classes from scratch, and I want you to assure me on time practice, on time submission of assignments. If not on time, at least by weekend, please make sure you submit all your assignments throughout the course. On time practice and assignments by weekend max. In our data engineering classes, we are going to have 4 important elements. Number 1, something called ETL. I said something because I assume we're all very new. We are going to have ETL, extract data, transformation of data, and loading of data. ETL we call data warehousing, big data, and analytics. To implement these 4 elements, we have other blue items. Data Factory, Azure Data Factory, Azure Synapse, Azure Databricks, Azure Data Lake, Microsoft branded items. Open source items, Spark, Python, Spark SQL, PySpark, Scala, OSQL, OData, etc. Open source. So we have Microsoft branded elements, open source elements to implement these pink items. But what are these? Let's get started slowly. Agenda for today's class, we'll understand what is database first. We'll start from there. What is warehouse? What is ETL and what is engineering? What components we need to learn and master practically in our classes, the prerequisites and the course takeaways. These are only PPT slide for the entire course. From next class tomorrow, straight into the practice step by step with detailed printed notes into your hands before the class. Let's get started slowly, step by step. What is Azure and why we need it? Yes, to understand what is Azure or Azure engineering and why we need it, let's take a look at database, a platform to store any type of data, any amount of data. Very simple and straight. A platform to store any type of data, any amount of data, no exceptions. And basic types of databases, OLTP databases. What is that? Live online transaction processing databases, OLTP. Usually SQL developers will take care, database programmers and developers will take care of OLTP database design. You and me, data engineers, we are responsible for data warehouse databases. BI developers, business intelligence, they involve in OLAP databases also, online analytical processing databases. Now the question, how these 3 are related to each other? 3 different databases, 3 different bread slices, and the actual jam between them, the binding colorful tasty agent, ETL, extract, transform and load. OLTP, online transaction processing databases to store live real-time data like live temperature, live stock market operations, live online banking, live online reservations. In one of our class examples, live IoT, Internet of Things. Data warehouse databases, to store historical data, temperature, like old temperature data, old stock market data, old bank statements, anything old, anything stale, or anything which is inactive. But this history is important for further analytics, forecasts, machine learning, deep learning, data science projects. Data warehouse is the boss. Data warehouse is the godfather of any BI implementation, and this is our course. Any BI implementation, business intelligence model, various OLTP systems, enterprise databases, our ETL, the binding gelling agent, is going to the extract, transform, load ETL technologies are capable enough in extracting data from various sources, identify the trends, filter it, slice, dice, grade the data, and carefully place it in a warehouse. From this warehouse comes reporting, analysis, mining, etc. This warehouse can be very important. This warehouse can be one single database, Spark. What is it? Spark. Spark database, part of our class. Or the warehouse can be implemented as a collection of databases. We call it pool. SQL pool, Apache Spark pool, serverless pool. We have three variants of pools in our classes. Microsoft brand. I repeat again on my screen now. In our engineering, we are involved in ETL, open source, Databricks, Microsoft Data Factory, ETL, and data warehouse. Open source single database Spark or Microsoft brand. We have something called pools. What is it? Pools we call. Synapse SQL pool or dedicated SQL pool, Apache Spark pool, serverless pool. Three different brands, three different variants of pools are available. All those three Microsoft pools need some way or the other, they need SQL Server. SQL Server is the prerequisite for our complete practical course. From very next class, next minute. What is it? I said SQL pool. It is a concept. I don't want to use the term copy. I don't want to use the term copy, but my feeling, I have experienced a similar concept in Snowflake. Yes, Snowflake is an open source data warehousing system that has collection of multiple internal databases inside it. The same concept came into our Azure as well, our holy friend. In olden days, warehouse used to be implemented as one single database in we used to Azure, formerly called SQL DBA, and before that to call it as parallel. Now comes something called pool concept. And what is this pool? Collection of databases that we need to work with. When we say collection of databases, we need a server and we need SQL Server part of our classes throughout the course. So our data engineering involves ETL and pool of warehouses. Let's imagine that way in an easier way for practical activities from next class. From warehouse, once we get the godown ready, then comes analysis, reporting, mining, deep learning, data science, machine learning, etc., etc. So what exactly is the data engineering here? It is a prominent job role for design of warehouses. But not only that, when you compare a Snowflake engineering or AWS engineering, GCP, Google Cloud, GCP engineering with Azure engineering, here we have a lot of beauty for a cheaper price. Yes, amazing extraction activities, nice user interface, and faster, efficient data cleansing, accurate transformations with immediate preview, almost immediate, next second preview. Sorry, next few milliseconds preview. Very, very fast transformations. And big data storage, security, and optimizations. There are few other engineering technologies that do not have their own storage. They depend on Azure. Azure is a boss. I repeat my statement again. There are few engineering technologies at open source that do not have their own storage. And Azure is a rescue team for them. Azure has its own storage. Azure has its own governance. Azure has its own private and public cloud environments. Our projects are safe and our client team is safe. And no one else is going to take over us. We have seen a lot of clouds, right? Last 1 decade, changing the companies. And some are boosting and others are dying. Azure, we are safe. Azure, we are safe. For example, friends, I'm talking about one such example, Talent, ETL, Tableau, ETL. They changed their hands. They got their hands changed. Few boosted up like anything and few were down. We are at Microsoft, the godfather, the big brother of cloud, and we are safe. Azure has its own market share with respect to storage, ETL, and integrations. I was telling friends one simple point few moments back. I said few open source warehousing technologies do not have their own storage. Let me justify my statement. Snowflake.com. Friends, we need it for our classes. We are into Azure engineering, but as an Azure data engineer, sometimes we need to work with Snowflake engineers also. Why? Reason, Snowflake needs support of other cloud platforms like Azure. Snowflake is a flight. It needs one of these 3 airports to land its data. And we are choosing this colorful Azure. I mean to say, friends, don't see Azure as an individual unit. No, not at all. Just like the recruiters asking multiple technologies in our resume, yes, we need to have that kind of integration in our learning as well. Azure and Snowflake are good friends. Azure and open source Databricks are good friends. What I said just now again, Databricks is open source. We have Azure Databricks, AWS Databricks, GCP Databricks. Databricks is open source again. So remember, we need to learn their friendship as well. Azure has good amount of it says like of. I got one question on the chat in the meantime. 1 minute. And ETL, right? Yes. It's ETL and ELT both. Yes. Talent, Tableau Cloud. It was taken care by Salesforce, right? And once the moment it was taken care by Salesforce, see, why is a different story altogether. But what happened to Tableau Cloud? What happened to Tableau projects? Why lesser renewals of Tableau projects in the recent past? Who is the promoter of Salesforce? Google.com. One of the names I found, Bill Gates. It all depends. It all depends. We are at a safe side. We are safe. Azure is safe. AWS is safe. These clouds are safe. We are safe always. Azure and Amazon cloud, the safest clouds, at least for me. For me, they are safest clouds. What about Google Cloud? Yes, Google also has data engineering, same storage, ETL, and good amount of activities, but I may need to wait for some more time to see more number of data centers for them. Let me show you what I mean. Really, friends, we need all these items. I think I closed it. I think I closed it by mistake. No problem. I'll show you. Go to snowflake.com again, or even databricks.com, any open source. Friends, we need all these. We are learning for our job work. We need it. Yes, the moment you go to Snowflake or any other open source environment, you take Azure, more number of data centers. You take AWS, more number of data centers. Of course, bit less compared to Azure, bit less as on date. If it is Google Cloud Platform, GCP, list is still only 4 items here. Network coverage, cloud network coverage, satellite network, the cloud storage. My clients are looking for more. Secured, more, cheaper, and instantly available. Prefer to go for Azure if you are looking for something which is cheaper and colorful and safe. Let's get started now. As a data engineer, either you go for Google data engineering or AWS engineering or Azure engineering, these three engineering prominent job roles, it's all about design of warehouse. In Azure, faster and cheaper warehouse. Any engineering, extraction, cleansing, and transformation in Azure, it is very accurate and cheaper. In Azure, we have unlimited big data storage at a very, very cheaper price. Enhanced security. You say, hello, Microsoft, I will pay more. They'll give you more security. More optimizations. In our classes, please write this number somewhere in your notes. If you are maintaining it, in our classes, we have total of 21 optimization techniques. Why 21? Simple. There are storage optimization, warehouse optimization, extraction optimization, cleansing and transformation optimizations. Apart from this, analytics optimizations. 20 optimization techniques we need to learn throughout the course together. The 7 to 8 weeks journey. So it's all about storage. It's all about ETL, extract data from various sources, transform it, carefully shape it, and load it to a warehouse. In this process, we have open source like Spark SQL. Spark SQL is one term. Scala, Python, AI and IoT part of our classes practically. Here is a component list. We have ETL components, Microsoft open source, data warehouse components, Microsoft open source, storage staging components which are common for Microsoft and open source ETL, Microsoft and open source data warehouse with complete project implementation part of our classes. I request you to do only one thing, on-time practice throughout the course to enjoy its actual beauty in an easier way. We need to work with various kinds of data sources, database sources, files, and applications. Few applications we will install it in our local computer, few other applications from browser. And we have open source ETL, Microsoft ETL, and the gelling agent in between them, Synapse. Open source warehouse, Microsoft warehouse, and a common friend for both of them called data lake. These are all back-end activities left side. Front end is Power BI, a separate 1 month journey. If in case you are planning for certification, here it is, the certification path. You are aware of SQL concepts. Please revise them. I know you are aware of them. You are aware of the course prerequisite, MS SQL, TSQL. Queries should be enough. Programming not required. Queries should be enough in Microsoft SQL. And from there, you go for data engineering, DP203, complete guidance part of our course. If you are into Power BI as well, additionally PL300, part of our Power BI separate 1 month course. Fabric now became 6 weeks course, 6 to almost 7 weeks. To step into Fabric, we need data engineering and Power BI. Now what is Fabric? Very simple. In olden days, we used to have SSIS separately, SSRS separately, integration services ETL separate entity, reporting services separate entity. Blended together, we used to have something called MSBI. Same way we have Fabric. Fabric is a unified end-to-end BI implementation. In data engineering, we pay for ETL separately, warehousing separately, staging separately, pipeline separately, notebook separately, script separately. Really. So like, it's like a la carte. Again, Power BI report separately, a la carte. Fabric is a single weekend Sunday brunch. Really. One single license for warehousing, ETL, pipelines, notebooks, scripts, staging, something called Polybase, something called Spark clusters, analytics, reporting, dashboards, apps, everything together, single license. That is Fabric. But let's speak the truth. Again, my experience, my observation. I'm only talking about my experience, my observation, okay? Let's be very cautious while we are speaking public. We should be cautious. My experience, my observation, my understanding, not many companies are into Fabric. They are planning for it. They are planning for it, but not into it right now. Maybe due to the prevailing economic conditions, or maybe due to the licensing cost, or maybe due to few hidden costs in Fabric. There are. We cannot say no to our experience, right? Many companies are into these two elements. Again, usually your companies can use core engineering and Power BI, everything together for a same project, single project, or depend on Azure data engineering for ETL and analytics, and depend on Snowflake for warehousing. What does it mean? Here it is. This warehouse is there, right? Instead of Spark, they can use Snowflake. Snowflake, data lake, Synapse, together one warehouse bundle. Notebooks, and pipelines, Databricks, Data Factory for ETL projects. So combination can be in any way. It depends. But remember, from broader angle, data engineering is all about two important departments, ETL department, warehousing department. We are learning both, gelling together. So in our data engineering course, keeping in mind our flexible resume, we'll take data factory, data lake, Databricks, PySpark, Synapse, IoT, Purview, and Big Data. After we learn all these elements in the project, we have one example for Snowflake with Azure, so that we can include it in our resume. First thing. Number two, it will be surely help us in our project implementations. I repeat, along with our Azure engineering, we have Snowflake integration with Azure. I said they are good friends, and their friendship means a lot for our resume. I repeat again, Snowflake is a open source cloud. That Snowflake cloud and our Azure cloud always, they can sail together. In not always, few cases they can sail together for something called as external stages and something else called incremental loads. I understand we're all very new to Azure and engineering activities, but we need to keep in mind our lengthy and useful resume, keywords of resume. So the black box part of our classes with Snowflake touch in our course. So what we learn here in data engineering. Before that, please revise your MS SQL concepts. By end of next week, sorry, by end of this week, better by end of this week, please revise DDL, DML, select constraint joins and database diagrams in OLTP environment, regular SQL. By end of next week, please revise group by, merge, normal forms, rank, basics, very basics of view, procedure, and functions. Please revise them. First line by end of this week, second line by end of next week. Any doubts, clarifications during your revision, do use me. Let me know. I'll be available on WhatsApp and email. We are starting our data warehousing course from tomorrow, complete engineering stack. Fundamentals will start with database concepts. Pool means collection of databases. I was mentioning a few minutes back. Pool means collection of databases. Storage, stream analytics, Databricks, Data Factory, Synapse, Key Vaults, Active Directory, also called Entra, Microsoft Entra. IoT hubs, event hubs, monitoring, alerts and resource management activities. Then we have something called implementation activities like ETL data warehousing concepts with Polybase, migrations, web applications, live streaming, clusters, PySpark, notebooks, etc. Python, part of our classes from ETL perspective right from scratch. No separate course for Python required. No prerequisite needed for Python. Part of our classes I'll take care. We have 25 examples on Python with ETL. 25 total, including the task items. Enough. We are not into Python programming. We are into Python for ETL. Same way, in fact, Python is also required for Power BI. That is a data analyst course, separate course. We are into core engineering with AI, technically, practically for DP203 examination. With this information, now the course is split into 3 independent modules. Storage and data lake, minimum 2 weeks journey, Monday to Friday India time. And then data factory 3 weeks journey, Databricks 2 weeks journey. Total 7 weeks, final 8 week is for the project and integration. Snowflake with data factory, Snowflake with data lake, logic apps, CI/CD pipelines, etc. Mainly from resume perspective, we'll take it in our classes. So end-to-end integration part of our classes, and coming to the examples, they go this way. Number 1, I trust you. I trust you. You are cautious, you are serious with your course, so we are sailing together on the same boat from tomorrow. Really, I trust you. I want interested participants in my class, please, so that I can stay longer, because I want to be the only one here at my school for Azure. I want to stay longer. I want interested participants. Sessions will be completely in detail, step by step, with complete notes sent in advance. Every 2 weeks, you take print copies of the notes, get them ready beforehand. Let's involve, let's interact, let's discuss after every example. And we involve more, we respond more, we submit more assignments, we get more and more. Same is the story for every module throughout the course. Need your response, need your interaction. Let's show our interest towards the technology. Let's show our love towards the technology. It is going to give us more than what we expect in our life. My experience. Every session will be detailed, step by step, back to school. No second thought. But I want you to involve, practice on time, understanding the things slowly, step by step. Whatever we are learning today, for example, I said something called Synapse. I said 3 pools, right? These are the 3 pools I was mentioning few minutes back. It all depends on what is what, when to use which. And I was mentioning something called 20 optimizations. Few of them on my screen. About 13 or 14 on my screen right now. So this way, the things are bit vast, bit vast. So we love it, we care for it, we are safe. Need your support. Concept of Spark, Python, will take it from the very basics. As I promised earlier, we have good amount of examples for Python and Spark. Right from the basics, we'll do one by one. We have good amount of synopsis every now and then to get more control on the subject, to get more control on what we are learning and what we need to learn next. With this information, final part, final point. What about the project? For our resume, we have a nice project. We'll take it right from the requirement to step-by-step solutions. If your interviewer asks you what you did in the project, what are the challenges you face in the project, what are your roles and responsibilities in the project, and so on, we will be taking it for sure, step by step. With this, we'll stop for now. Next, over to you. Please let me know questions, clarifications, and we'll take it from there. Need your support. Let's make it a cautious, friendly, useful journey. I want interested participants. I don't want to miss you. Please. Hope you got what I mean. I don't want to miss interested participants. Let's love the subject together. I need it. Any questions now? Tell me, friends. Everyone, yes, please. On-time practice throughout the course. Submission of assignments by weekend, please. Everyone, please. Yes, please. Yes. Mic with you all, please. Yes.
Yes, Prananda. Yeah.
Yes. Will do.
Perfect. Thank you. Thank you so much. Thank you. Others. Ankit, do you hear me, sir? Ankit, Mamata, Mohammed. Yes. Right.
Yes.
Yes, sir.
Perfect.
Yes.
Thank you. Thank you so much. Thank you. Thank you. Yes. It's your response that drives me, right? Isn't it? If I am cautious, you are serious, we can have nice class, right? Yes or no? Either online or classroom, it should be the same thing, right? What do you say, please? Yes?
Yes.
Yes.
Yeah.
Yeah, it's
That's
not
correct.
like, okay, someone coming here doing some magic show and going away. No. What about tomorrow? What about tomorrow for you and me? We need it. Let's look for tomorrow. That is more important than today. We'll do it slowly. My complete support always. Thank you, attendees have been responsive. Really appreciate. Next questions for you now. Please let me know. I'll wait.